Hello, I want to talk a little bit about making solutions in a molecular biology lab. So one strategy that we use is we tend to have around the lab bench more concentrated stocks of solutions that we use regularly, which we will dilute as needed to their working concentration. So I want to talk to you about a couple of techniques that we can use to determine how to make the appropriate dilution. So let us imagine that you need to make 200 mils of a 50 millimolar tris Cl solution at pH 7. And let us imagine then that we poke around our lab bench and we note that we have a bottle on there, and that bottle contains some 1 molar tris Cl pH 7. So the question we want to answer then is, how much of this concentrated stock do we need to put in 200 mils in order to make it be 50 millimoles? So one strategy you can use is a formula that you may be familiar with, and the formula goes like this. It's C1 times V1 is equal to C2 times V2. And what do all these letters mean? C1 is always the starting concentration. That's the concentration of our stock. V1 is the amount of that stock that we're going to need in order to dilute it appropriately. So this is what we're solving for, our X. C2 is our final concentration, which is, in this case, 50 millimolar. Okay, so that's the final concentration. And V2 is the final volume, so it's going to be 200 mils. So I'm going to go ahead and fill out the numbers here. So you may note that the starting concentration and the final concentration are in different units. The starting concentrations in moles, ending concentrations in millimoles. I'm going to then convert them both to millimoles. So 1,000 C1 is 1,000 millimoles multiplied by X, which is what we're solving for, is equal to C2, which is 50 millimoles multiplied by 200 milliliters, which is the final volume that we want. And I'm going to go ahead and solve for X in this equation. Okay, so the millimole units cancels, and as we would expect, our final units is milliliters. And so we can see that we will need to pipette 10 milliliters of this stock of a molar tris into a final volume of 200 mils in a graduated cylinder. We're going to add 10 mils, we're going to bring it up to 200 mils, and that will make us our desired solution. Okay, so a second strategy, one that I use, especially when the numbers are fairly straightforward like this, and it means I can sometimes do them in my head if the numbers are easy. So what I would like to do when facing a problem like this is I like to think, what do I have and what do I want? And I know that I have 1,000 millimolar tris Cl, and I want 50 millimolar tris Cl. So that tells me that the dilution factor, the factor by which I need to dilute this stock, is 50 in 1,000. And then I can quickly do some canceling here, and I might see that if it's 50 in 1,000, I would need to dilute by a factor of 5 in 100. And I can quickly see then that in 200, I would need 10 milliliters. So that's a quick way you can think about them.